Hello everyone, I'm Salih and welcome. Yes, you are right. You read it right. Stephen Toub made a mistake. Before we go even deeper, I just need to say something. It's because I feel I have to. I'm not going to say anything bad about Stephen Toub. It's because I can't. It's because he's one of what I believe is he's one of those greatest mind of all our time in terms of the computer science. He's I believe a genius of programming, I could say, or as I said again, computer science. I'm not gonna say anything bad, but this is here. So if you don't, please check. Stephen Toub made a program with Scott Hanselman on dotnet's YouTube channel, I would say, and they call it deep.net. He's been basically simplifying things, complex things like span, like async await, like regular expression, and also he's trying to create everything from scratch. But as I just said, by simplifying it. For example, if you want to know about async await, how task basically works in .NET, you can just go to watch that video. If you want to know how regular expression or regex works, so you can just go to a website where you can find all of those deep.net titled videos. For example, I'm now just looking at async await one. What we have here, they also talk about task and parallel programming. They also talk about link queue. So he was able to create these IEnumerable and link queue functions from scratch. But as I just said, it is oversimplified for us to understand. I don't really remember how many times I have watched that async await videos. I had a bunch of questions everywhere in my mind, but those questions were basically answered by those videos. So it is a great video, but also it is a high level video, I could say. Even though he tried to simplify it, it was still high level, I would say. That's why it took me a couple of times to watch it. Also, I was basically doing the same thing what he did in that programming. And I found the bug. Actually, there are two bugs. In that video, I'm gonna talk about that bugs. But also, as I said, I'm not going to say anything bad about Stephen Toub. It's because I can't. So I'm a huge fan of his, and I believe he's one of those has the greatest mind. He was trying to simplify things for us to understand easily within this complex things like async and await. But in that video, he made a mistake. I mean, it is not a mistake. Maybe it is some sort of things that he was aware by the time that he was making this video, but he wanted to simplify things for us to understand. Maybe that's why he just skipped that. But there is a bug. Actually, there are two bugs. I'm just going to show you what are those. If you want to implement the same thing, I'm just going to point out two stuff that you should just avoid using. It's because if you're going to use the same code that he has produced in that video, if you're planning to use in production, do not. It's because it's got bugs. So I'm just going to say a bug. I'm just going to show you the bugs. Let's check the video. I mean, I'm not going to watch it over here, but I will just share the link in the description below where you can find. He was creating everything from scratch, as I just said, and he was using my task my task class. The code also after video was published on James Montenegmo's GitHub account, and all the usage examples as well. So what I did is I copied that into my Visual Studio, where I will be showing you the bugs, I could say. But it may not be a bug. It's because maybe he was aware of this stuff, but as he wanted to simplify things, he just ignored that. But as I just said, if you want to use those code in your production systems, please do not. So I've just copied that one. I will show what it is basically. So I copied my task class. It is a representation of tasks, I could say. And he also implemented awaiter struct, I could say. So you should be able to await with that one as well. And all over here, I'm not just going to explain what he did in that video. Watch it first, and then we will see. So in our example, let's say I have a task. Let's call it my task.run, as I would just do with a normal task, not my task. So let's say I have a function, action actually here, and says log function says main method, right? So it is pre, and I will have post as well. So it is a basic action. So in that action, I'm gonna say sleep like 3 seconds. This is pretty simple actually, right? So what I'm expecting, this task will be running in thread pool. So it will be picked up by thread from a thread pool and run behind the scene. And afterward, it is basically, if you take care, if you want to know about this completion or continuation, you can just attach something. But as I just here, I'm not doing it. So basically I will run that task and leave it. So fire and forget. I'm not going to wait for it. Once I run that application, what I'm gonna see is that pre-main method, and then 3 seconds later, I would just see post-main method. This is perfectly normal. As you just see, there are 3 seconds there. First problem here, if you want to make it, let me show you the second one. So as this is a returning task, this task has a continuation, so continue with function as well, which requires an action or a function and returns my task in case of you still want to use a task in that action. So what I'm gonna do, I'm just gonna say, okay, this is the action. In that action, I want to log something. Let's say continue with worked. This is gonna be my task, and as this is returning task, I'm just going to ignore it, right? Discard it. I'm now going to run the application again. Watch it. So what I'm expecting is pre-main method, post, and continuation, right? This is a perfect, so it's still working. Where things get complicated, the first scenario is if you want to make this async, so this function normally, the run function accepts action, bigger, accept action. If you want to use async here and says, okay, return me a task or just do something with await. So instead of this one, let's call task delay with the same parameter, 3 seconds. Now what we are expecting is still pre-main method will be printed out and wait 3 seconds, and then post main method will be printed out. But let's see how it's gonna be, and then the continuation. So what happened here was pre-main method printed, and then the continue with worked, and then the post main method. There's a problem. So this one should have been printed after we see this, is because this is the main action. It should be completed first, and then it is going to call the continuation function. Then this action, this part will be printed, but there's a problem. But this is not the even biggest problem over here. So I'm just going to return it back. So we can live with that. The problem here, if you watch the video, if you really watch the video, you will notice, so this task, so this continuous returns a task, but I discarded. So this task is awaitable. So basically I can call await task. This would be first. Or if you still see inside and get awaiter, if you call, for example, get result function, so get awaiter, get result function, it is going to call twait, so tasks wait. So basically this means task get awaiter, get result is equal task wait. But no matter what you do, this is what's going to happen. But if you use await, what's going to happen is that in the ion level, there will be state machine created. And again, this get awaited, get result function will be called, but then it will be event based. So your ID, so your compiler doesn't have to wait for that. It is going to assign it to another thread and register itself for the completed event. And then the other thread is going to run that action. Once it is done, it's going to call you back. In that case, your application, your main thread or whatever thread you are creating this thread from is not going to be blocked still, so still will be able to do anything else. But it really doesn't matter. In our case, as this is a console application, this 3 line basically is doing the same. But I'm just going to call wait function. So what happens, let me show you. So what we what we saw earlier, let me show it again. Pre-main, continuation, and post, right? This is what we saw. Wait, I switched it back to sleep. So what I see, pre, post, and continuation, perfect case. So if I wait for that task, what's going to happen? And we are still expecting to see the same thing. But what happens here is just pre-main method and post-main method will be printed. So where is the continuation? Where has it gone? So that function never ran. So you might think maybe it is ran, but we didn't catch it. So let me put a debug pointer here and see. Pre-main method after 3 seconds exactly, post-main method. So the continuation just gone away. So we overridden that continuation task. If you again watch the video, you might just notice that it may be something that Stephen Toub was aware but didn't want to mention in that video. It's because he doesn't want that he doesn't want that the video took like 3 hours, 4 hours. Maybe he was not aware, but he just noticed later. Maybe he wasn't bothered to fix it somehow. I'm not sure. It is not a big mistake. So as it was a demo, it was simplifying things, like complex thing like it's task and await. He was basically simplifying it. Maybe it was an incident, I don't know, but I'm just going to show you why we are having this problem. So what happens when we are using not my task, but task? So if the problem exists also in my tasks, let me try to it. So when I run this application, what's gonna happen is what I expected. So I will be seeing main method, and I will be seeing post method, and I will be seeing continue with work. But the problem doesn't exist in the current implementation. But as I just said, Stephen Toub was basically simplifying things. So it is not easy to explain everything, task, the complex object, complex type, in a live demo application for 1 hour. So maybe he was simplifying thing and he just missed that problem. And I will show you what the problem is actually. And also I will show you how they fixed it in task, in the actual implement. The problem happens in the continue with action. If you watch that video, you might just notice that problem. What happens when we call continue it, and when the task completed, what's going to happen? I will show you. When we call continue with function, we pass it an action to it, which is this action over here. This scope is my continuation action. I'm passing this, and it gets in and says, okay, if this is completed, what is completed? The actual task, in that case, this one. If this is completed, it can call it right away, right? So if I didn't wait over here, basically it's gonna print this one and print this one. By the time the compiler executes that line, the main task, the actual task, would probably be completed already, and then it would print it. Let me try. So as you just now, it's overridden again. Let me wait here. Task delay like 1 second. So to make sure by the time we call this, the actual task would be completed completely. So as you just see, okay, we see the pre and we see the post and continue work after that. So as I just said, by the time I call the continue it checks if the main task is completed or not. If completed, it can run the callback function, which has my action in it. Basically, you can assume it is calling that action right away. Not right away, but queuing. It really doesn't matter right now. If it is not, it is storing the action to be called later, to be fired later in continuation action. This is important. In our case, let me put it back. In our case, by the time I call that continue with an action, it is storing that function to be executed later. So it is again actually fine over here. But what happens when the actual is actual task is completed, which this awaiter and get wait function, it does that. So when onCompleted event is fired, it calls continue with the continuation action, which means if the main task is somehow completed, it is continuing with the continuation action. So once we get into that one, it is again, if it is completed already or not, then done, two things. But what happens is basically set result is because if you go to run implementation over here, what it does, it executes the action in a thread, in one of those threads. It executes that action and call afterward, if there is no exception, it calls set results. Once we get into it, what we'll see is complete function will. Once we get into complete, it first check if it is completed already. If not, mark it as completed and gets the execute exception if there is any. And then after run is completed, it checks the continuation. If we have any continuation action, then it says, okay, I'm not going to get into this execution context, but it executes that continuation, right? So this makes perfect sense. This run function does something, so executes that action, that scope, and then it checks if I have any continuation action over here, which makes perfect sense. If so, then the run function is basically calling that action, the continuation action. But if this is the case, where is the problem? Why we see that line before that line? The problem happens when we wait for it. If you remember, it's because if I don't wait for it, I will see what I should see: pre, post, and continuation. I wait for it. If I have the wait, I see pre and post. My continuation will be overridden. It's because of the logic we have in wait. So let's get into wait. So wait function says, okay, I have a manual reset event, or MRES, I would say, and Slim. What it does, it blocks the current thread that is run on, and then it tells other thread, okay, let me know when you are done so I can let the current thread go. So this is what we are using, why we are using manual reset event. It's got a set function, it's got a wait function. What happens here, it waits for anyone, calls set function of that MRES, and also it is setting, okay, I have continuing with this MRES set. So what happens here, when you wait for function, it says I am in my task object already. When anything happens, when this task is completed, the continuation will be MRES releases. I know it is a bit complex, but what happens here is that once we get into continue with, it overrides. It overrides our continue with action. So this is our continue with action. When we call wait, before this is executed, if we call wait, we are overriding this action. So in the perfect case, in the perfect scenario, what would happen? Run is going to call that action, and then it is going to call that action, right? But what happens here, by the time run finishes its job, I already overridden the continuation function with my own. So I'm basically blocking the thread, the main thread of, not main, but the thread that my task is created on. I am blocking it, but also saying any other thread will execute my main function, and once it calls its completed function, then the complete function is going to call continue with function. So let me show you again. So once we call complete, where is it? Here. Once complete is called, it checks the continuation and then executes it. But when I call wait, what's the continuation function? Is going to be my reset release function. So it's going to release my function. So then the compiler executes the rest of it. But as I just said, I know it is complete. It's a bit complex. It is really difficult to understand, but this is what happens. I'm going to try to explain again. By the time run finishes, this 3 seconds, it needs to call the continuation. But the continuation function normally is that function, right? So continue with worked logging, so printing this line. But when I call wait, I override that function. Now the continuation function is basically the action. So that action, it is going, instead of calling this bit, it is calling this bit, so my current task can continue. So the problem is here, as you see, we are overriding the actual value on continuation. We had the already continuation function, which is something else. And then manual resets events set function is overriding it. So the problem here, as you just see, we have only one continuation, but we might have multiple continuation, and Stephen Toub was aware of that. I think that this was a mistake that he did intentionally. This solution for tasks, so why we are having it only my task but not task? If we go to source.net website, and if we see the source code for tasks, if we get under continue with function, what you will see basically validates the situation and calls continue with core. Once we get into that function, continue with core, what you're gonna see is again checking the validations if it is completed or not. But it says add task continuation. So instead of having a one copy of continuation action, they have a list of it, so a collection of continuation. It might have more than one continuation as a chain, but each continuation maybe executes the other one, or all the continuation list will be consumed by any other stuff. It really doesn't matter in that case. But once we get into add task continuation, and what we will be seeing at another function, add task continuation complex, once we get into that, now we will see there's a list. Basically, they're collecting all the continuation in the list and making a bit comparison if it is already completed one, or if it is the one already executed or something. But instead of having one action only, they have a list over here, and they do all the stuff by doing anything. But this makes perfect sense. The problem exists here in my task, but not as task. As I just said, I'm not going to say anything bad about Stephen Toub. He was probably most likely aware of that, but he didn't want to bring it in, because that would make video 3,000 hours instead of 1 hour. It was really difficult to explain everything and create that my task from scratch in a one video. If you want to know about this stuff, please watch his series. Scott Hanselman is having the guest as Stephen Toub, but he also mentioned that he is going to have someone else's from .NET team for another concepts. So if you want to learn more about this stuff, please watch that all videos in .NET channel. And Deep.NET is only one of those series. They've got another series as well. The Microsoft MVP on development technologies, I've been watching all of those. I am a huge fan of Stephen Toub. I'm a huge fan of Scott Hanselman. But I just felt I'm responsible to point this out. There was a bug in that code in case you might just want the same code in your application. This is it, actually. There's nothing else I can explain to you. If Stephen Toub is watching that video, hi Stephen. And until the next video, happy